Great, good afternoon, everybody. It's always a great privilege to be here at AWE every year and see the progress that everybody's making in the critical technologies to make all this happen across multiple platforms, multiple applications, etc. Just a quick check, if you bear with me. How many in the audience are more on the hardware side versus software? If you just raise your hand for hardware. Okay, and software? Great, that really helps me out. Thank you, thank you. Great, so what I'd like to do is explain a little bit about a technology. I'll stay fairly light on that, and then move on to some exciting new applications that we at DigiLens have been working with our partners on deploying in a broad range of applications. And that's the key thing about augmented reality. There's such a broad range of different applications, from the traditional founding applications of representing data over the real world in aviation, through to automotive applications with the classical head-up displays, and now in all these marvelous other applications involving consumer eyewear and the ability to both extend that safety of the use of head-up displays to people, and beyond that, obviously, entertainment and retail and advertising and all the other great things. So really, it's a broad range and a diverse range of different applications that we're all looking forward to. And DigiLens today are fundamentally involved with many of them. And that's one of the distinguishing aspects of our unique waveguide optical platform technology. It really can spread right across the whole spectrum of augmented reality applications. The key thing about our technology, we think, that distinguishes it is that, or the key breakthrough, is that we are able to print these nanostructures into waveguide optics, these eyeglass displays that you may have seen or we will look forward to. Printing these nanostructures in there guides the light to create a very large pupil in the eye to give you a nice augmented reality view. And I'll show you some of the products that we've developed in that area. The thing about using these nanostructures in the particular material system, which is another distinguishing feature of our technology, the unique material system that we use, but the thing about this is that we've had to actually extend physics. We've had to take some of the fundamental laws and theories of physics involving Kugelnick, etc., and extend that with our own unique tools. So the core to our technology is this photopolymer. It's an advanced photopolymer, optical photopolymer. And what we do, as I'll explain in a moment, is we coat a sheet of glass with it, we encapsulate it, and then we expose it with these nanostructures. And the way that we do that is we use a lithographic master. We bring coherent laser light through it, and we literally scan these structures into the waveguide structure. And that waveguide can be an eyeglass for your eyeglass display, or it can be a very large waveguide that we use in the autoHUD. So really another key aspect of our technology and the breakthrough is that we can scale to these other augmented reality opportunities and platforms that are needed. In the area of eyeglass displays, one of the key things that you may have become frequented with as we all get used to HoloLens and to Magic Leap and other companies that are developing waveguide optics is that the image comes into the waveguide and is basically periscoped into your eye. But in doing so, it passes through these diffractive nanostructures that does what we call a two-axis pupil expansion, which is a critical aspect of magnifying the image and allowing you a very large, relaxed eye box. So as you're walking around with your eyeglasses, you can clearly see the augmented or the digital representations over the real world. So the light comes in at the bottom, it propagates across in one-axis pupil expansion, and then up vertically into the eye box, and then the diffractive structures diffract it out of the eye box and into your eyes. So hence you see a very relaxed image, as I explained. What's unique about our photopolymer technology is that in the diffraction of that image as it passes through, is it does not one interaction, as it does in surface relief, but mysteriously two interactions. And this dual interaction gives us a very distinct advantage, especially in wide field of view, because it actually magnifies or doubles the angular response of the image. What that means is that we can create these waveguides with a much wider field of view as opposed to other techniques such as surface relief waveguide optics that you may be used to. I'll only throw this up very quickly, but just to say that we've had to do some fundamental work in extending these laws of physics, if you like, to cope with this birefringence in our type of photopolymer. And we've developed tools so that optical engineers can add these to their conventional toolkit, bolt them on, and allow them to do a full systems integration and a full systems technique so that they can actually design the different products and see cradle to grave the performance of those products. So that's very important, to have the tools that optical engineers can use to create these new products using this fundamental technology that we provide to manufacturers for augmented reality applications. It also turns out that there's a whole variety of unique ways that we can use these structures and place these structures in the line of optics, if you like, where the image comes in as it propagates through the waveguide and up and out of the waveguide. It turns out that these structures you can literally record, if you like, and then take out of the CAD system and put in place, rather like you do in electronics with IP cores. We call them optical IP cores. You're able to take these predefined structures, put them in turn, and actually develop your systems of the optical system at a systems level, the full performance of the device. These are a little bit more about our tools, but nonetheless, we've created applets that are very easy to use and enable the optical designer to work efficiently in creating these waveguide structures in that regard. And we actively train other optical designers from other corporations in how to use these tools and then hence how to make their own products using this optical platform technology. Just a little bit about our manufacturing technology, because as we move forward in augmented reality and look forward to consumer augmented reality devices, manufacturing and ease of manufacture and hence the price of manufacture is a critical aspect. And today, surface relief waveguides, as in HoloLens and other examples, are made by using a full-blown silicon fab. All the necessary equipment, the etching equipment, the photolithography equipment, the methods of recording these structures are ultra precise and done in a very expensive environment. Are those type of waveguides ever going to achieve consumer price point? Who knows? In our case, we wash a piece of glass in the top left-hand corner. We put the glass onto a little printer belt and we print or coat using an inkjet printing technique. We inkjet coat our material with this very thin photopolymer. It's only a few microns thick. In the next step, we simply put a top cover on it and encapsulate it. We put it in the fridge. In the next step, we come down and we print the nanostructures. It's just like a photoscanner. It just scans it across the bottom and scans these nanostructures into the waveguide. And then finally, we do an inspection of it, pass, fail, put the two together, and now you have your eyeglass display. So fundamentally, it's a very inexpensive and very scalable technology to make waveguide optics for a variety of augmented reality applications. So in terms of utilizing that technology and waveguide optics, we're applying it to very large displays and very small eyeglass displays. And I'll come on to show you a few of those applications. In the area of large displays, we've teamed up with our partner Continental, who is #1 in HUDs for automotive applications. And we've developed a unique type of waveguide optic for everybody's car to provide a wide field of view. In fact, we demonstrated at CES a 20-degree field of view HUD for automotive augmented reality applications. In that realm, once again, we go back to that early example I explained where we do this two-axis pupil expansion, input, fold, output. And so you can see that we apply that here in exactly the same way, only it's on a much larger scale. Input, fold, output. And these structures are here in this picture of the actual demonstrator that we showed at CES. So the fundamental methodology by which we're able to manipulate light and expand it into this collimated image needed for augmented reality applications is absolutely identical in principle. The only thing that's changed is the scale. We can also add additional features to it where we can manipulate the light holographically to correct for curvature on the windscreen, for example. This is particularly important because if you look at the complexity of conventional wide field of view HUDs, you start getting into the realm of needing parabolic mirrors, other more complex assemblies, things that have really limited the application of head-up displays in the automotive area for many, many years and really rarefied it to an expensive accessory that many people just can't afford. Interestingly, when people do have HUDs in cars, the attach rate is phenomenal. Nearly 95%, some of our customers tell us, people who have HUDs will never give them up because they're so much easier to use and so more convenient than having screens down the side of the car or having dials and everything in front of the car, because clearly you're taking your eyes off the road, which in many cases isn't a good idea. And so it is, if you took all those mirrors to try and create a wide field of view HUD, in physics, you'd end up with a projection system that is tens of liters of size. Clearly impossible. You'd never fit it under the dash. Clearly never happened. And the breakthrough of using waveguide optics is that you can create a very small discrete device that's thin, and so it will easily be accommodated in these new interior designs. So from large, we go to medium, and how, again, waveguide optics has revolutionized HUDs in aerospace. Here our partner is #1 in aerospace, which is Rockwell Collins, and they manufacture all the HUDs for many aircraft frames, both large and small. But in particular, in small aircraft, you can't fit a giant projector overhead and a holographic combiner, which is a traditional way of doing HUDs in aircraft. And so it is that we generated a waveguide type design for them and implemented that in this very compact HUD, which is a waveguide HUD. There is no projector. And as you can appreciate, the real estate over top the pilot is very, very expensive. And so now this type of HUD can be fitted in small regional jets, in business jets, etc. So a whole variety of smaller aircraft or aircraft that couldn't otherwise afford, because that's the other thing, is the price compression, couldn't afford a more elaborate overhead projection system with conventional HUD. So in that regard, again, waveguide optics revolutionizing head-up displays for aerospace. But it's really in consumer and the opportunities in augmented reality for consumer that we're so excited this year. We've taken the fundamental teachings of these platforms that we've developed and now are bringing it to consumers. And with our transportation heritage, so to speak, what we've done is to really bring that to motorcyclists, as it started out, but now has turned into what's called the smart helmet market. The smart helmet market is really addressing consumers' need to stop looking at their phone when they're traveling at speed. And whether you're traveling on a motorcycle or traveling on a bicycle, very often you want to have your music, you want to have your navigation, you want to have your communications, you want to be answering text. You probably really didn't ought to, but voice communication and voice analysis is getting so good now that it offers the opportunity of really having a head-up display and voice together as the whole means of interaction with the actual device. And so it is in the motorcycling area. We're developing with several partners. And last week we announced Senna, which is pretty much #1 in the motorcycle communication market with their mesh network technology and their Bluetooth technologies for voice reception, etc. We're combining that all into an integrated helmet and bringing that to market in the third quarter of this year. So we also announced at CES earlier this year that we'd signed up with Young Optic, one of the leading optical manufacturers. They'll be manufacturing the mono-HUD, we think probably the first augmented reality consumer HUD. This is a $399 retail device. It's extremely inexpensive. It uses conventional Pico technology. And as you can see, it's very easy. You can fit this in the helmet. In fact, you can fit it to any helmet in that regard. Of course, there's going to be many developers. And part of us being here at AWE today and this week, we have an exhibition. Many of these can be tried on the show floor, is the outreach to developers. we're really interested now to engage in developers, not just for this product, but a couple more that I'll be coming on to. And we'd love to see all kinds of developers bring forward their products.
Ready, 30 seconds.
This is shot in San Francisco.
We are HUDway. We bring new technologies, simplicity, and safety to driving. We made our products from drivers to keep eyes on the road, mind on driving, and stay connected even behind the wheel. And we bring our new products to life here on Kickstarter. HUDway.
We think there's many applications for this, this personal HUD, and we're certainly, as I mentioned, very, very interested to engage with developers and work out ways, no matter what the application, that this simple, low-cost consumer device for augmented reality could be applicable. Our second eyewear product that we've just started to demonstrate now is, we're particularly excited, called autoHUD. And this is a very, once again, low-cost, lightweight, simple companion to a cell phone. You plug it into the cell phone, USB-C, it draws the power, it's all-day wearable because it's so light. And we think that there could be many, many enterprise-type applications that this could be applicable to. One of the keynote things of autoHUD, and this is the actual prototype, is you'll see it's so transparent. And the very same components here are in this device here. It provides a very bright, extremely bright, actually. We've recorded up to, well, in some of the hero parts, 16,000 nits, which is obviously way too bright. But of course, brightness really is all about efficiency. And we haven't seen this in waveguide optics before. The efficiency in our devices is considerably more, we think, than surface relief devices, giving you daylight opportunity for the display. And again, there are many, many enterprise applications we think that this could be applicable for. And our simple mission is to connect this to a simple Samsung cell phone, which has a USB-C outlet. And under Android, this could be used for many applications in that regard. In the area of wide field, as I mentioned earlier, the DigiLens optics are able to go much wider field than conventional surface relief, just in physics. Bragg optics, which is what ours are, have a much wider field capability. In that regard, we've been working with Rocco Collins. If you could put the sound up on this one, just to show you. This is a world's first waveguide optic digital night vision system. And this is having a huge reception in the military community.
Now visually you see
it's the first time that they've had a waveguide optic display replacing the large tube intensifiers that you've probably been used to, watched and seen on the movies, with a simple waveguide optic that can be clipped over the top of the helmet.
We've had night vision goggles, we've had head-worn displays. What IDVS does is bring both of those capabilities together into one system that supports us.
So we think waveguide optics can have a great application here, where the wide field of view provides obviously the peripheral sensibilities, and in obviously a mission critical task like this. It's also being used in daytime as well for lighting up environments and for detecting friend and foe. So we've really taken that wide field of view optics experience, and our third product that we're bringing through this year is called autoHUD. And in that regard, once again, you'll see the transparency of the display, very high brightness, high efficiency device that can be used in a number of different applications. Now, it's important to recognize that these designs I'm showing you here are all reference designs. The intention is to get these out into the developer community, into the OEM community. Everybody will have a different interpretation. Our job is to make it as easy as possible for those developers to access the technology and develop, the products that they have for their specific applications. And in that regard, we've hooked it up to a head tracking sensor and a hand tracking sensor, to produce a device that provides a very wide field of view, good transparency to the eye, very bright, and frankly, very simple. The device at the moment is around 55 degrees field of view. That will escalate as our projector manufacturer widens their individual pico projection lenses and take that right up towards 90 degrees field of view. In the future, we have plans to go much wider field of view than that, but certainly for the near term, that's really our roadmap for this device. So we think that AR-HUD, again, can have a rich opportunity in terms of the applications of wide field of view, augmented reality in either gameplay or commercial or business or enterprise applications, all of them in that regard. And so we're particularly excited by mono-HUD, by iHUD, and by AR-HUD serving 3 individual segments of the future augmented reality opportunity. So once again, appealing to the development community, if you have projects that could involve this type of technology, we'd certainly very much like to hear from everybody, and count DigiLens as your partner on this fantastic mission that we're all involved in. Thank you.